Mm. Infinite loops in coding. The dangers of infinite loops in programming. Presentation overview. Infinite loops. Learn what infinite loops are and how they can be problematic for your code. Causes of infinite loops. Explore the causes of infinite loops and why they occur in your code. Preventing infinite loops. Learn effective strategies for preventing infinite loops from occurring in your code. Understanding infinite loops. An infinite loop is a loop that runs indefinitely and does not stop until an external event occurs. It can cause problems for your code by tying up system resources, causing your program to crash or freeze. Definition of infinite loops. An infinite loop is a loop that runs continuously without stopping. This can cause problems because other parts of a program may not be able to execute properly while the infinite loop is running. Causes of infinite loops. Logical errors and poorly written code are primarily causes of infinite loops. Logical errors occur due to incorrect algorithmic design, while poorly written code may not have proper exit conditions or may have unintentional infinite loops. Logical errors. What is a logical error? A logical error is a mistake in the way that a code is written. Unlike syntax errors, logical errors do not cause the program to fail. Instead, they cause unexpected or incorrect results. Examples of logical errors. Examples of logical errors include infinite loops, incorrect calculations, and incorrect data comparisons. Poorly written code. Poorly written code can cause an infinite loop, which is a situation where a computer program gets stuck in a loop and is unable to exit. Preventing infinite loops. Understand your code. Understanding your code and the logic behind it is critical for preventing infinite loops. Make sure you understand the variables and the conditions that control the loop. Limit the number of iterations. Limiting the number of iterations can help prevent infinite loops. Use a counter to keep track of the number of iterations and exit the loop when the counter reaches a certain threshold. Use break and continue statements. Using break and continue statements can help prevent infinite loops by allowing you to break out of a loop or skip certain iterations based on specific conditions. Best practices for writing code. Proper syntax. Writing code using proper syntax can help prevent common programming errors and ensure that the code is readable and easy to understand. Testing code. Testing code before it is deployed can help prevent bugs and ensure that it works as intended. This can save time and effort in the long run. Debugging strategies. Debugging strategies can be used to identify and resolve issues in code, including using a debugger tool, logging data to identify where the loop is occurring, and using techniques to limit the number of iterations in the loop. Conclusion. Infinite loops can be a serious problem in coding, but they can be prevented by following best practices for writing and debugging code. These include clear and concise code, setting up break conditions, and testing code thoroughly before deployment. Thank you.